All right. Good morning to those of you in the United States and where it's still morning in the world. And good afternoon to those in Europe. We're super excited today for the WorldViz SightLab VR Pro webinar. We hope that you will find by the end that this is indeed the easiest way to build VR experiments. So we're really excited. It's going to be a great presentation. We're looking at about a full hour runtime. We'll go over the entire schedule of events for today, but we had a ton of attendees. So just giving it a couple minutes while everybody drizzles in here. So yeah, this will be recorded, but it's great to be here live because we will be taking a lot of live question and answer. So we're looking forward to your feedback as the presentation goes on. So yeah, since we got a lot to cover, I think we'll just jump right in today, and folks can join midstream, and that's no problem. So let me go ahead and do a quick introduction to the presenters. So you should see all three of us here. First and foremost, we have our main presenter today, Seda Rabouty, the product manager for both Visit and SightLab. Awesome. And then we have Kenneth Karthik, who's the lead developer for our SightLab software. So, and I'm Dan. I'll be basically your MC today. So I'm the head of sales here at Americas for WorldViz. And yeah, if you guys have any questions throughout this whole presentation, we invite you to use the questions and the chat feature that are on the GoToWebinar dashboard. So really quick, let's just go over the topics we'll be covering today. First, we'll give a quick introduction to what WorldViz is. I'll cover that. It won't be very long at all. And then we'll hand it over to Sato for a conceptual overview of SightLab. From there, we'll do about a 20-minute live demonstration of actually building a VR experiment on the spot. So Sato's going to configure a scene, run it in a headset, show you how easy it is to actually just get an environment and start collecting data. After that, we're going to go through all of the different example scripts that are included with SightLab. So we'll get into this in more detail, but that's 90 plus example scripts, templates, modular pieces of code and scenes that you can mix and match to create your VR experiment that are included with the SightLab software. After that, we'll hand it over to Kenneth, and he's going to do a pretty cool deep dive into the actual underlying algorithms for how we calculate eye tracking data. So this is super valuable for researchers, anyone who wants to know, hey, how is this data actually being calculated? We're going to talk about that, how the SightLab API works for creating custom code with the SightLab code base. After that, we're going to finish it up with a few real world examples of use cases and case studies that are out there, different customers who are using WorldViz's software in their research every day. Finally, there'll be a Q&A at the end. So like I said, submit your questions as we go along. We'll be monitoring the chat throughout the webinar. So we might actually pause things if there's a question that comes up that's super pertinent to the topic at hand. So we really do invite you just submit questions as they come up, and we'll have a dedicated question and answer at the end. So this whole webinar is timed out at about 55 minutes to an hour. We could go over a little bit depending on how much QA there is. So yeah, looking forward to that. Really quick, without too much more pause, about WorldViz. So if you're unfamiliar with our company, we build VR labs. So for over 20 years, we've been a preeminent provider of research VR solutions to higher education, academic research, and industrial clients. So our focus is really on that R&D market, creating VR software and VR hardware solutions that are well geared towards the actual folks who are on the cutting edge of creating new VR experiences. So that's really us in a nutshell. We won't be talking too much about our hardware today, a little bit towards the end when we look at some of the case studies. But in general, in addition to the software that we provide, we also produce integrated hardware solutions. So we'll build out VR labs for places like Stanford and Yale and Harvard. So those are just a few of our customers who we've built hardware solutions for. So if you're interested in learning more about our hardware, we're happy to have a one-on-one conversation with you about that. Before we go on, we wanted to learn a little bit more about you as an audience. So I'm going to go ahead and send this out. This is a question about what hardware you're currently using. So we kind of assume at this point that most of you are using some kind of VR headset, but basically, or familiar with eye tracking in general. So if y'all could just go ahead and submit your answers to the poll. We will share this with everyone, so it's really exciting to see what the answers are. I'm seeing very few people are using augmented reality. A few are using screen-based, so we're still getting some responses here.
Yeah, or I'm assuming some people are probably using more than, I mean, multiple ones of these, but maybe just
Yeah,
the
and
most
it's
prominent.
what's pretty cool is so far of all the respondents, over half already have eye tracking VR headsets, which is just a testament to how much this technology has proliferated in the last 5-6 years. Because I mean, we remember when you couldn't get an eye tracking headset for less than $20,000, right? So I'm going to go ahead. Thank you everyone for your votes. I'm going to close the poll and share this out right now. So as you can see from the results, we're looking at 51%, almost exactly half, are currently using eye tracking VR headsets. So that's great. You'll be able to walk away from this webinar with tools that you can use today. 31% are using non-eye tracking VR headsets, which is also great. We're going to actually cover some of that. SightLab is really useful for folks who don't have eye trackers as well. And then screen-based eye trackers, no VR. That's definitely kind of an emerging area that we have some tool sets for. But then 10% no hardware yet, new to eye tracking. And again, we have a huge catalog of past webinars that I'd really invite you all to take a look at. The one that we just did a couple weeks ago was how to budget for a VR lab. So if you're looking at getting new hardware, we did this super deep dive into the whole VR hardware spectrum. And it really will give you basically a complete market overview, hard numbers for what to purchase. So I definitely recommend checking that out on our website and on our YouTube page. I'm going to go ahead and one final slide here before I hand it over to Sato, and that's just a little bit of an establishment of terms. So if you're new to WorldViz and you're new to our software, you might be asking yourself, what is SightLab VR Pro? So SightLab is a hybrid SDK plus GUI tool. So it's got both code and menu-based graphical user interfaces for creating VR experiments. It's really geared towards VR experiments and researchers. And it's all built on top of Vizard. And Vizard is WorldViz's proprietary VR engine that is based on Python. So all the code that you'll see today is Python based. SightLab we use a little bit interchangeably with Vizard because it's based on Vizard, but just to establish some terms and to get everybody on the same page, SightLab is a hybrid SDK plus GUI, and it's built on top of Vizard. So without further ado, I'm going to hand it over to Sato now, and he is going to give us a full deep dive into SightLab. Take it away, Sato.
Yeah, so thanks, Dan. And it would be a lot to cover everything that we can offer with the software, but I kind of just wanted to highlight some of the main features and hopefully kind of be able to communicate the ease of use and the functionality, and also very much the extendability, because this is all completely open to whatever research that you're looking to do. But the main sort of high level features is that this gives you the ability to create complex VR experiments with little or even no code. So I'll show kind of how that works, and that it has a lot of built-in eye tracking analytics, which Kenneth will be talking a little bit more later, and some of those algorithms. And then you can get an interactive session replay along with the recording, so that also will provide things like visualizations of heat maps and scan paths, and that automatically is going to be available, and I'll demonstrate that. And then you can save and collect all the data, do data analysis. And this works with both 3D models and 360 media. It'll accommodate for multi-user experiments, so you can have people even in different locations, even in different hardware types, and that they can also run a session, and you can collect the eye tracking and user data and even the physio data from all of the multiple participants. And there's, as Dan mentioned, a very large library of customizable examples and tools, which, I mean, we won't be able to cover all of those, but I'll kind of give you an overview and highlight a few of them. And we have a very powerful connection with the Biopac Acknowledge software. So if you're using that, we have a very easy integration where you could just immediately synchronize with the physio data and be able to do things like biofeedback and look at the average heart rate, or send events over to Biopac, which automatically, you don't have to add any code for doing the bulk of that integration. as well as easy connection to a lot of additional hardware types. So with like EEG devices like the MetalOp device or FNIRS or full body motion tracking if you're doing things like XSense or OptiTrack or data gloves. I mean, it's over 150 different hardware peripherals, and this is leveraging sort of all of the years of Vizard's sort of way to add all of these hardwares, and this could be like omnidirectional treadmills, screen-based eye trackers. I mean, there's a very exhaustive list. And then I'll also demonstrate the custom AI assistant that we've been developing that has access to all our documentation and code. And this is actually pretty interesting that you could generate experiments just immediately that you can run and see how things work and ask questions. And so I'll demonstrate that. And as Dan had mentioned, this is based on the Vizard engine, so that's Python based. So the coding, if you're going to do coding, it'll be Python. And then it's a VR development engine with easy hardware connectivity and access to very low level data collection. And so I'm just going to jump right into showing a quick demo. So this is basically a project, and I can just drag and drop in 3D models or 360 media. So this is a model that we collected with a photogrammetry, but I'll show you in a moment a lot of different resources that you can use for getting assets. But you basically just drag and drop in a model, and then we have, if you click edit, this allows you to bring in like this 3D editor tool. And so from here, I could do things like maybe I want to start off by deciding where someone is going to start in the scene. So this avatar object here is saying when somebody puts on a headset or they're starting, this is where the participant's going to be. So you could kind of move that around or maybe change their viewpoint. And this could be even different if you have multiple participants, you could set different starting points. And then additionally, I could say maybe I just want to do like a region or area of interest. And so we have this tool we could drop in that you could add to multiple spots in the scene. So we're automatically going to collect data on everything that someone's looking at, so scan paths and heat maps, but this gives you the option to have additional data like view counts and dwell time and things like that on these areas of interest. And then because this is all going to save into the data file, it's probably good to just add a name for that. But if I jump over to this asset browser, so we have a lot of assets already kind of built that you could just drop right in, like we've already prepared these, and those are objects, avatars, 360 media. But additionally, there's a lot of content libraries. So these are ones where you could use like Sketchfab, and there's over 150,000 Creative Commons free models on here. I know now they've been migrating over to being Fab, but both of those are accessible and they have a lot of models, and these are kind of other libraries. And also there's now, as you're probably aware, a lot of AI content generation tools. And if you do like an image to 3D, you could just upload an image of an object, so you don't even have to do photogrammetry. You could just turn it into a 3D model or even use text to 3D. And we even have examples of doing this in real time now too, where you could just put on a headset and just kind of create a scene on the fly. But if I go back to Sketchfab and maybe I want to just really quickly add an object to my scene, I just click downloadable and I'll just select this chair. And now within just a few moments, I could just click download 3D model. And what I recommend is the GLB format. I mean, these other ones will work because we work with all the major model formats, but I find the GLB is going to give you the best sort of results consistently. And so now if I actually go to webinar, things in the way, sorry. Okay, so now I could just add this to my scene. And now I have the ability to move this object that I just got off Sketchfab. And this would be, if you got this model from anywhere, it's the same thing. You just drag it in. Now I could kind of place it where I want. Maybe I want to change the rotation. And already I can now collect data. So this will come in as an object of interest, and it'll give you the option to say you want to collect view counts or dwell time or average view time, and also grab and interact with the object. And you could give it a name if you want, but I'll just click save. And then I'll close this, and now I'll go back over to this interface, and I'm going to click the refresh button. And now I have these objects that I could say, maybe I want to grab the chair, maybe I want to grab the plant. This first line of checkboxes is saying these are some of the objects of interest that I want to collect additional data on. And so I could check that. And then up here is, I'm just going to give this kind of a label so I can know what this is. But this would also be like if you're saying this has a different condition, like maybe this is a low light environment, or maybe there's something different that happens in here. So this will go into the data files, and this will also allow you to do sort of like parsing through the data to check against different conditions if you put this label in here. And then we have the ability to use different sort of methods of how you go between the trials. I mean, you could set like a timer or custom event, and this could also be like a gaze event or a trigger event. So anything that could kind of allow you to go from one trial to the next, but the default, I'll just keep it as key press. And I could check if I want to do practice trials. And I'll just generate a few more kind of sample trials real quick. And the next thing that I'll show you is that we can also bring in like 360 videos and images. And this is also just drag and drop. So if I basically just drop in this model, and now I could even tag some regions of interest on here, and I could kind of resize this or move it and give it a label. And by the way, this also can work with the moving regions, but that's through a different example. So this is just showing you just a really quick way to tag some of these objects, and I'll just call that tire. And then you're going to want to reduce the opacity so that the participant doesn't see that. And then I could call this parking lot. And for the last trial here, I'm just going to show you just really quickly how I can go back to my asset browser. And if I had like an environment, say that I got off a Sketchfab, or I'll just choose this environment, I could just also drag and drop that straight into the GUI and just use that immediately. So now I could drop this in here, and now I have this model. So now I just drop that in, and now I'm just going to have this Jeep model as just a sample of another type of environment. And then I'll just click done. And now on this screen, I could add some additional options, like maybe I want to randomize and run these as blocks of trials, or if I wanted to choose a different avatar. So, and actually, let me go back to, yeah, so I'll click done. And then if I choose between different avatars here, this would be for the multi-user. If I wanted to say, like, even I could use a photo to create an avatar from a photo. And that would be if you're having multiple participants, that would make sense for that. And then I'll just choose the Glowman though. And here, Kenneth will go a little bit more into detail on this later, but this is also where you could set some eye tracking thresholds, like dwell time, and like this would be set to 500 milliseconds by default. And the fixation duration is set to 1 degree of angular distance. If you're within that threshold, it'll be collecting a fixation. And then it's over 100 milliseconds of time would also set that. And so you can see I just had these 3 trials here. So I'm just have these objects that I could collect data on. And then I have the second one, which is a 360 video. And then this third one, which is the Jeep model. And so now I'll click done. And now I'm just going to click continue, and then I could see, hopefully this headset is still running. And I'm just going to be running the Vive Focus Vision here. So we could choose from a lot of different types of headsets. You could also, if you're not running an eye-tracked headset, you could choose like MetaQuest 3, and then you'll just get head positioned for the attentional data, or I could run desktop as a prototype mode. But I'm just going to choose Vive Focus Vision, and then click OK, and let me make sure the headset's running. I gotta have a controller's charge. And this is where you can put in a participant ID if you want, or a name, and this can be customizable as well. And so now I'm just going to press spacebar, and that green point that you see right there, that's the where I'm looking. So that's going to be the gaze point, like the midpoint between the pupils. And so that's going to collect data about where I look around in the scene. And we have different methods that you could use if you aren't able to walk. You could use like an arc teleport transport, or you could use this kind of magic carpet mode, and I could grab these objects and look around. And this is just collecting data about where I'm looking and what I'm interacting with. And if I go to this next scene, I'm just looking around in this 360 image. And then for this last one, I'm just in this model here of this car. So now I could look around in here, and I could look at the mirror, and this is kind of collecting the data about where I'm looking here. And now after I ran that, the first thing I'll show you is now all of that data can be visualized and viewed. And so if I go to back to my folder, and by the way, I just ran this shortcut to get to my sample project there. This is where you would have your project saved. And now if I run the replay, I could view this in a headset or in a desktop, but like you could actually put on a headset and walk around to see what a participant is viewing. But I'm just going to view this in the desktop, and I'll choose my session that I just ran. And so now I could play this back with the visualizations. I could pause this. You could see here's the pupil diameter. This is giving you the timestamp. I could change some of these parameters, like the view of the heat map and how that looks, or I could toggle that off, or this is showing you the scan path here of where you're looking. And then I could toggle that off, and you could see these points of fixation points of where somebody was in a fixation. So I could kind of scroll through this, or I could even move around and see from different viewpoints. And then if I go to the 360 image, you get kind of the same thing. You get the heat map and scan path and looking at that. But then, and all of this can be customized, or I could use like a first person mode or toggle off pupil diameter. There's a walk path that you could view, and Kenneth will go a little bit more into detail of this later. But what I wanted to show you next is if I just open up the data folder, and then I go here, this is all of the raw data that we've saved. And so now you can see that we have the timestamp, and this also gives you a Unix timestamp that you could synchronize with other programs. And then when I start collecting the eye tracking data, you see there's the combined and individual eye position, the eye rotation values. So if you're doing like convergence or things like that, you get the 6 degrees of freedom of the head. And by the way, this can be added to very easily with just like one line of code. You could add, if you're measuring something else, maybe you want to add heart rate, or you want to add hand position, things like that. It's designed to be very simple to do that. And then if I was within 1 degree of angular distance for over 100 milliseconds, it's going to say that I'm within a fixation. And then otherwise, it's going to collect these points as saccades. And when you're in a saccade, you get the saccade amplitude. So it's frame to frame, it's going to show you the amplitude, the saccade velocity. And then when you're at the end of the saccade, it gives you the average amplitude, the peak velocity. And then you have the pupil diameter, and this is also for individual and combined eye, as well as the eye openness values. And then you have these custom flags. So this is saying when you looked at an object or when you grabbed an object. And by the way, that's also, since I had the acknowledged software running, that's also all collected here as well. So this is saying I was looking at the right mirror since that was the last trial. This would show that all into the physio data, which I was running just some sample EEG data. And then in addition to this raw trial data, there's also a timeline. And this will just say, what are the objects in the scene and what was the sequence of which ones you looked at? And then if it was over 500 milliseconds when you looked at that object of interest, what was the dwell time? And then how many fixations were there while you were in dwell? And that's kind of a timeline overview. And then if you go to the summary, this is where you can kind of see, like, for the whole experiment that you ran, what was the total view counts on the objects you were interested in, the total fixation counts on those objects, the total dwell time, the average saccade amplitude, average saccade velocity, the time to first fixation. And this is also one you would want to modify, like if you want to say, for instance, which I'll show you in a moment, like a visual search, and you want to see what was the time to find the target object, or what was their average heart rate, or what was like the whatever kind of dependent measure that you're looking at that might be affected, you could put that as well into this file. And everything that I just showed right there was just, I didn't have to write any code. I just basically dropped in some stimuli and I got all of that data. And now I could also, I didn't record a video, but you could also have the option of recording a video, which then gives you the ability to do like a, this is one I'd recorded before. If you're looking at the Biopac physio data, I could also go and bring in a video file. And now what this is going to allow me to do is to scroll through the physio data. And again, this is just sample physio data. I'm not wearing an EEG, obviously, but you can now see when somebody was doing this experience, what was their physio at that moment. You could scrub through, and this could be heart rate or respiration. And then you have these sort of points of event markers. And then I'll show you in a moment too that we can also bring in the physio data into the scene to do biofeedback, where you could change something in the scene depending on what the physio data is. But that also, it just doesn't involve any code. I just click the checkbox for that. And let me go back to my slides to see. Oh yeah, so the next thing is, I was just going to explain that to do the multi-user, it doesn't also, you also don't have to do any code. You just run the server script on one machine, and it's the same method. You just can drag and drop your models, or you could go and, which I'll show you in a moment, there's this, if you wanted to modify things, you could add a little bit of code, and that's where it just opens up this Python editor. But you don't have to do anything extra for the multi-user. You just run the server, and then you run the clients on the other machines, and they could choose their avatar. Oh, that's the Dan avatars. That's yeah, so you could just choose whatever client you want to use. And then the multi-user then allows you to run with multiple headsets. So this is just showing like multiple users with their data collected. And this could also work for 360 images. You could look around inside those. You can get the walk path. So this is showing 2 users, and it's showing their path as they walked around through this apartment, their various walk paths, which are color coded. And so now for this first demonstration, the last thing that I wanted to show you is, so if you did want to modify things with code, or maybe you weren't sure of what to do, as I showed you, it's not really much code and it has all of the documentation. But what makes that really easy now is I could go into this custom trained assistant, and I could say, for instance, like, how do I do a gaze-based interaction? So this is saying, like, if you look at an item, something is going to happen based off of that you looked at it. And you could say, show me the full code. And now it's going to give you the instructions of how to do that and give you a working sample that will just, you could just run immediately. And this is whatever you can think of. I mean, that you can ask of this assistant. And honestly, I mean, I've even uploaded PDFs of experiments to this and said, can you run this in VR and show me how to do this in SightLab? And within about 10 minutes, I had something that was working. But this is basically just now it's setting up the scene, choosing an environment. It's adding a cube, which is just like you can have these built-in shapes if you just want to easily just add something. And then it's doing the gaze-based event to say when you focus on that cube, then it's just going to print out cube was gazed at. and then it's giving you some instructions saying, look at the cube. So if I copy this into the Python editor, and this, by the way, is the Wizard IDE, which is where you would kind of be doing any coding. And I'll just save this and run it. And I'll just kind of choose desktop now. So I'm saying, look at the cube to trigger the event. And this is the cube. And now it says cube object was gazed at. So that's a very simple gaze-based experiment, but you could see that I just got that within a few seconds. So and that's just scratching the surface of the power of this, because you could dive pretty deep on getting some pretty complex experiments put together, just because of it's kind of leveraging the tools that we have built into SightLab and Wizard, but then also the ability for this agent to be able to access those tools. And then the next thing, which really kind of advances the features and functionality that you can get out of this, is all of the custom tools and features and example scripts. And these are all customizable and modular and extensible, so you can mix and match, and you could customize these. And a lot of these are also set up that you could even leverage them without even having to code anything, but then they could be also added to with code. But so this is just kind of a page where you could see an overview of all of these different things. So if you want to add like a 3D menu, or maybe you want to add avatars or biofeedback, and I'll go into a little bit more detail on some of these in a bit. I'm not going to cover all of them, but or if you want to add like a user survey before they start, get like demographics or add instructions, do augmented reality. And then on this other tab, so there's different kind of categories, but this one, these are kind of more like full experiments that you could just run, for instance, like if you want to do a public speaking study, we have a public speaking study you could use. You could do distance perception, choice comparison, but they're also fully modifiable, like reaction time. So for instance, like the visual search, like we have a whole bunch of different visual search paradigms, but they're all designed to be customizable. So you could see, like you could set, if you're doing a conjunction or a feature search, how many distractors you want, how many trials, what's the environment, and then you could set like what is the range that the objects are going to appear, what are the objects that you're using. So it's designed to be fully customizable. And also, just to show you really quick, like say you wanted to do like face tracking, you click on this page, it's just one line of code. You import a module that gives you face tracking, and then you have the ability to collect all the 60 points of face tracking data, map that to an avatar. Or if you wanted to do like the AI agents, then you could see there's just a couple lines of code to add that. So you just import that and you could just have an avatar. But to kind of highlight just in a little bit more detail some of these. So I mentioned visual search, and that gives you the ability to choose different ways of randomizing the objects. That could either be that you choose from a grid, they can all kind of appear within a certain location. They could be randomly dropped using physics. They could be placed specifically in spots. You could choose whether the target's going to be absent or present, or do different kind of trial logic. And this is obviously fully like modifiable. You could go a lot deeper depending on if you're doing a more complex study. But this just kind of shows you like this is a shopping one. This is saying find this item. And so I modified it so that I'm having to look for the tuna. And because there's a lot of similar looking objects in here, it can be a little difficult because you kind of can't tell like which one exactly it is. But then when you find it, you get some visual feedback. So I think, yeah, I find it there. And now it's saying I found the object. And now this is going to be saved to the data file saying that the time it took me to find that object. But now afterwards, because of the replay, now I could look and see when somebody is scanning to find that object, what was the pattern they used, what was the pattern they walked, and what did they focus on a little bit more. So maybe when I'm like grabbing these objects, where do I look around? And it's going to give me like the fixation points, the heat map, and all of that. And then this is all just automatically going to collect all the data and synchronize with the physio if you're using that. And then, and yeah, so this is showing like So this is kind of based on the Randy Pausch visual search, just kind of leveraging the template of where you could place all these letters around and things like that. And by the way, when I'm running the I don't know with the videos, but definitely if I'm running the VR application, it might look a little choppy over GoToMeeting, but it's just the connection. It's actually not choppy. And if you have any questions also, like while I'm doing this, you can put those in the question chat and
Oh, we're getting a lot of questions in the chat here, Sato, but it's all good. So we'll have a great QA at the end. So I really appreciate everyone's questions that are coming in. So keep them coming. But yeah,
Okay.
keep going, Sato. We're all good.
Yeah, so this is a basic example where one of these objects is a different size. It could be smaller, it could be larger, and I could specify that parameter, I could specify the objects, and then I get this built-in selector tool. So that's another way of selecting and saying specifically this, I think maybe is the one that's smaller. And then you get your confidence showing, this is showing like when somebody puts on a headset, they would see this anywhere they look, and they could use the controllers to select their choice also and the instructions. But now I just kind of run 3 quick trials, and I don't know if I'm doing very well. It's a little difficult. But now after I run that, so in addition to the replay, we also have different ways you could visualize, like looking at the condition, like the independent measure versus the dependent measure. So I could say, what was the time to find the target versus object size? I mean, obviously this is also all in the data, but then you could generate these charts. So the time to find the target by number of objects, by confidence level, the count of how many I got correct by the size, by the number, by the confidence level. So I didn't get any correct, but this kind of gives you some different ways to visualize that. And let me just kind of go. And so this might be kind of quick going through some of these. We are going to share these slides with you, and you could also afterwards, we can offer you like a trial of the software and you could test it out, but I just wanted to highlight a few of these other ones which are interesting. So this allows you to bring in AI agents using large language models that could be, I mean, it could be any of the common ones like ChatGPT or Anthropic or Gemini, but now what's probably more even relevant for research is we can leverage all of the offline models like DeepSeek and Llama, so that you could run this without having to send any data over the internet. You could run it fully offline as well. And if obviously, you know, with AI, you could just use a text prompt and I could say, now you're an angry coworker, now you're an unattentive doctor, and it'll kind of, it does a very good job of adhering to that prompt. And then you could also have it just read customized scripts, because this, by the way, is using text to speech, and that could be using like 11 Labs or OpenAI or other text to speech models. And it also can use speech recognition, so you could just talk naturally with the avatar. And then this also, I mean, the sound's not on, but this, you can also, if you're doing kind of a instructional or training scenario, the AI can automatically give information on any object that you tag in the scene. And this is just using the name of that object. I mean, you could customize this a little bit more, but this is kind of just using that if you tag this object and it knows Mona Lisa or it knows like a wind turbine, it'll just answer questions about that. So it's kind of interesting. And also now with the vision capabilities, the AI also has the ability to know what's in the scene based off of the camera that's attached to its head. And just sticking on the topic of AI really quick, as I mentioned, there's AI creation tools, but now we can actually do this in VR. You could put on a headset and say, I want a tiger. About 30 seconds later, you have a tiger, you could pick it up and place it in the scene. And we have that working now with like Meshi and Masterpiece X and some of those libraries. This one is probably important to note that say you want to just use a regular VR application, or you have a Unity or Unreal game, and this is probably, I'm assuming a lot of you are actually in this kind of in that situation. So now you can choose to collect eye tracking data and synchronize with the physio on any application that's connected to the PC. And this is using this external data recorder. And so this allows you, it's still that you would need SightLab and Vizard, and you would run that as a layer, and it's going to take all the sensor data. So it's face tracking or eye tracking. And then we can now overlay that on top of this. This is like a Steam VR game. And then this is also running the Biopac. And then you could export the data. It'll also work with like screen-based eye trackers if you're running desktop, like Counter-Strike. But then for objects of interest, it's a little more tricky. So I have AI data analysis to look at the video frames to say, well, you looked at the character's weapon 4 times, the player's gun 2 times. And then you could also add, if you still want to collect demographics and add sort of surveys afterwards, since that's kind of wrapped into our software, that will work. And this is just highlighting biofeedback that you could bring in, like say you want to have your heart rate or your respiration change something in the scene, or maybe you have a ball that changes color and somebody wants to do like a meditation study, or they want to do some kind of like exposure therapy and they want to keep this ball within a certain range, that'll work that way. And a lot of the different tracking sensors that come in now, like face tracking, hand tracking, full body tracking, so we've made it very simple to add those to any script, like even with no coding. You just, as I showed you with face tracking, you just import a module, same as like hand tracking or full body tracking. And now you could, I mean, this one is just a specific example where I'm mapping it to an avatar in a mirror. So this is more of a example of showing that you could put an avatar in front of a mirror and I could move my face and hands and I could change the avatar. And this is an example you could use even if you just want to run this study. You just drop in avatars into a folder, or you could look at the face tracking sliders, or you could get like the data exported so I could see like the expression parameters and things like that for the face tracking. And then also, if you're using full body tracking, like the Vive trackers or Xsense or OptiTrack or something, this allows you to see your full body. So this is using the Vive trackers here. Or hand tracking. This one is actually set up to use physics on the fingers so I could interact with these objects and grab them. And this could also be data gloves if you're using like the Manus data gloves or something, but this here I'm using the MetaQuest Pro just for the hand, and I'm also measuring the distance between my fingers, and you could use hand tracking to kind of change things in the scene, stuff like that. And as I mentioned, these are all interchangeable. So this is showing augmented reality capabilities. This is built in, so you could do eye tracking on real world objects or add elements of holograms. But I mean, you could, for instance, bring an AI agent into a augmented reality scene with biofeedback and measuring face tracking, because all of these are just tools that can be combined together. But this is showing augmented reality that's getting more popular. This is if you want to, say, collect data on like standard content, like you have regular videos or images, you could bring in a virtual screen. And obviously in VR, you can make this any size. It could be a large theater or a monitor. And now you can collect eye tracking data and physio data and all of that data while someone is looking around at actual, like just standard images on a screen. And now we just recently added the ability to do screencasting, which brings in a lot more capabilities. This is now just kind of beta because we just added this, but you could, for instance, maybe have a PsychoPie experiment that's desktop. Now you could have people run that on a monitor and they could look around and get eye tracking data. Or for the multi-user, you could share like PowerPoint slides or a web chat. And then this is also showing you could even bring your phone. And so this is me using my phone, watching YouTube videos in VR with hand tracking. And this is all in real time because I'm just casting my phone to my PC and then sharing it on a phone screen, so I could do that. And then afterwards, it's still recording all of the screencast, so it saves a video recording of that. So now I could get the heat maps and all of that. And so if you're running that as like a browser-based content or something. This is just demonstrating we also have these like eye tracking tests, so like measuring spatial accuracy, smooth pursuit, or you could even do a study if you're just measuring like spatial tracking and you get the RMS and the error values and degrees and radians, or you could just look at these different targets and kind of get like an average. So it's also good for like validating calibration. And I just really quick wanted to also mention, like we can work with lab streaming layer because that comes in through PyLSL, and we could, then that allows us to synchronize with even more EEG devices or stream data into and out of SightLab using LSL. And then this is just showing some driving simulators. So this is one that's using like mixed between 3D models and 360 media, but you can still collect data in the scene or outside the scene here, like driving around, and then afterwards kind of view the replay. Or you could do like 3D model driving simulators. So maybe this one here is showing like traffic, so cars are driving by, or there's a pedestrian that walks in front of you. So that all kind of the driving simulators. I kind of mentioned this before, but this is leveraging like Matplotlib or Plotly or Seaborn or Panda or all these different ways that you could visualize data. Just additionally, you could just, we have examples, you could just add this to any of your experiments. And that's kind of just touching very briefly, because as I was showing you, there's a lot, and you could kind of look through those examples, but I just wanted to highlight a few. And then with that, I'm going to pass this over to Kenneth. And let me make Kenneth the presenter. And
Yeah, thanks a lot, Sato. Hope you can see my screen. Yeah, all right. So with that, I'm gonna start diving into the SightLab API, which is the underlying core backbone of everything that you just saw. So SightLab, like we've mentioned multiple times before, it is a Python-based application. So all the programming calls to actually utilize the API's functionality will remain on Python and will remain within our Wizard IDE over here. So what that enables essentially is this mixed workflow that provides a like spectrum of functionality based on your specific expertise. So on one hand, you can configure trials and media in a completely GUI based setup, just like Sato showed. But you can also like complement that with customized logic, events, triggers, based on like simple Python methods. And on the other extreme of that spectrum, you can completely build an experiment, just not even utilizing the GUI. That's a completely an optional layer, and you can build out your experiment completely on Python if you have that level of proficiency with Python. And what that enables essentially is the ability to import additional Python libraries, which is a benefit of just using that ecosystem. So this includes using data analytics tools, which are standard for your specific workflow, like NumPy or like DeepDiff or like pandas, whatever specific data analytics tools that you're already accustomed to, and you can plug that right into your existing experiment. And as for the code workflow, so focusing on the programming side of things, we've tried to minimize the amount of code it takes to actually get a project, an experiment up and running. So like, for example, what you see here is like 9 lines of code, and it already can run an experiment with a custom environment and a set number of trials and tracking a eye tracking object in the scene. So what we essentially offer with the API is a comprehensive list of like powerful events that are customizable, methods that can help you like specify details and parameters in your specific scene, all of which is linked in the documentation that we have online. But a few examples of that is essentially being able to show instructions, start the trial based on whatever stimulus you said, showing ratings based on specific research methods like Likert scales, etc., but also customizing the data output that you get, which I'll dive into further. But before we get into that, I'd like to elaborate a little bit on how exactly the saccade and fixation detection works on a higher level here. So I think you did see in Sato's demos that there was a stream of output that's given to you after you run your experiment. And within that, you do see a like frame by frame detection of whether the participant was currently in a saccadic state or a fixation state. The saccadic state being when your eye movement is at rapid speeds, and fixation being when your eye is actually in a stationary, relatively stationary orientation and actually absorbing visual information from their environment. So to help come up with that algorithm, we've based it roughly on the dispersion threshold identification algorithm, which was elaborated in the 1999 paper by Salvucci and Goldberg. In that paper, it's basically a comparative analysis. Is a very good read. I'd recommend it. In which it compares like industry standard methods for eye tracking, and that compares like the velocity threshold, the hidden Markov model, IDT, minimum spanning tree, and the area of interest algorithms. And what's concluded there and in a bunch of other papers that are heavily cited is that the dispersion threshold does offer better accuracy over the other models. It is relatively like fast enough for us to be able to do it real time, and it's highly robust, which is what our priority was, and relative ease of implementation. And it gives you two customizable parameters to actually morph it to your specific needs in your experiment. So how does our IDT algorithm work on a higher level? So the like I mentioned, there are two parameters. There's a dispersion threshold and a duration threshold. The dispersion threshold is essentially your visual angle of where exactly you're looking and how much of a threshold you're willing to set that would define a saccadic state right after that. So if you're looking at a certain object, say I set the dispersion threshold to a single degree, which is what our default is, 1 degree of visual angle. When I surpass a single degree from my target object, then I would start to be in a saccadic state. But that is combined with also the duration threshold. So that allows you to specify just how long that saccade, or sorry, the fixation state would be. So we've set that to a default of 100 milliseconds, but again, that's completely customizable. So in combination, what you get here is using the duration threshold, so 100 milliseconds, we create a sliding window over the continuous stream of data that we receive. And that window size is determined by, in this case, 100 milliseconds. And for each of the frames within that threshold, we check if your dispersion threshold remains true consistently. And if it is, it marks a fixation at that specific frame. And if that window has any sort of failures in between, it sets a saccadic motion for that specific frame. And yeah, what that allows is essentially a very robust set. So it's making sure that there is a window of your threshold being true to actually show that you're in a fixation or saccadic state. So like I said, both of these parameters are completely customizable. And we do also give like the raw data output if you want to conduct your own saccadic and fixation analysis. And to make sure that there isn't a high like a lot of these headsets do have certain glitches, so there are certain data points that go off, and we do pass it through a noise reduction filter using a moving average algorithm. Again, that's also with customizable parameters. If you don't want to smooth out your data and use the raw data, if that's what you're studying, you're free to just turn off the filter. So what that enables essentially is a very comprehensive set of gaze and interaction metrics, all of which are again listed in this link over here. But a summary of that is essentially like dwell time, so how often, like how long you've dwelled on a certain object of interest, or your time to first fixation. And on top of just saying that if you're in a saccadic or a fixation state, we also give you the amplitude, velocity, and peak, just like you saw in the demo. And that's also complemented with full 6 degree of freedom tracking of both your participant and objects in your scene. So you can track them along with the information from the eye tracking metrics, and also juxtapose that with additional physiological data if you're using Biopac, or face tracking and full body metrics, if just like we showed. And that also, so that's on the data side. And approaching things from this like data first approach, we also give you a way to visualize the metrics that we give you. So that includes, like you saw, just heat maps, which are again customizable in intensity, scan paths and walk paths, so your actual gaze path that your eye traveled through, and walk paths of like where the participant moved. We also draw a little logarithmic fixation spheres on specific fixations so that you can get a visual sense of where people's attention moved. And yeah, also the replay mode, as you saw, is fully scrubbable, etc. And in terms of the data files, we give you 3 data files. One that is a more raw data, just like I just showed. And then the second one is a summary report of like just how many times you looked at a certain object or how many fixations you had on a specific object. And also a timeline report, so a sequential report of what you looked at what time. And again, this is also done in a format like this. All our data files are in CSV format, so they are ready for any sort of importing into Pandas, MATLAB, or Jump, or whatever data analytics tool that you're currently using. And yeah, like I mentioned multiple times before, all our parameters and methods are completely adjustable and configurable. So once you get into the actual methods of SightLab, you have full control over whether you want to change the thresholds for how the detection works, or whether you want to change the actual columns in your data output. All of it is fully customizable on the researcher end. And this also enables gaze-based interactions, as you saw in the demo. And we do provide the events that enable that type of interaction. So you have control over like setting off an event based on when the object is first seen, or when you stop seeing it, or when it reaches a specific dwell time of how long you've been looking at a certain object. So you could open up a separate part of your environment, or like move on to the next trial based on a specific gaze event, for example. And also, again, based on research methods, we've built into SightLab a lot of like Likert scales, rating scales, just ready to use and customizable to whatever at whatever point you want within every trial or experiment. All of which is also data logged. And we also give you the ability to upload like text instructions, so you can just type out what they need to do. It shows up in VR. Or you could also upload an image, because we know a lot of researchers do have more complex imagery that describes what the participant needs to do, and they need that to be a control condition. So there's also the ability to just upload custom JPEGs for instructions. So yeah, with that, I'm going to hand it back to Sato to talk about our clients. Just a sec.
You have to make, okay. Okay, so I'm back here, and let me jump back to my slides. So, I mean, this is just a very small sampler here in this image, but since WorldViz has been working for over 20 years with academic researchers and clients, we have a very large clientele of people that are using our software. So these are just some ones that have been leveraging now the new tool of SightLab, and now highlighting some published studies that are interesting that I so this one is this one's using the Vive Pro Eye to measure how pupil diameter could correlate with cognitive load, and so they used a task evoked pupillary responses, and they had even an Arduino device to kind of compensate for the making sure that they could get the actual light that was hitting the eye and any kind of confounds, and they did find some relevance with that, and some did actually showed a correlation with pupil diameter and cognitive load, and this is the link to that study. Oh, and actually, before I continue with these two, I did want to really quickly, because I saw some of these questions, I think some of these are pretty relevant that I should have mentioned just really quick. So the ability to press buttons and interact with objects is built in because we have these proximity sensors, and that's a pretty important thing to be aware of, that you could touch an object or you could interact with something, maybe you walk over a scene, and this allows you to do button presses or interact in addition to grabbing, and that's why we have this 3D model tool or this 3D menu tool. And then I saw another one mentioning like expressions. So we have all of these different avatars do have built-in facial morphs, and some of them are even matched to certain expressions, or like with the real illusion, you have hundreds of facial morph parameters that you can map to different expressions. That's actually not me, I promise. That was a real illusion actor. But yeah, so we do have the ability to bring in expressions. I just wanted to kind of touch really quickly on those because I saw that in the questions. So to go back to these studies, let me just make this. And this was one that was using the multi-user SightLab and measuring using the Vive Pro Eye and Biopac FNIRS to create a smart learning app. This was developed by Siho King at the University of Oklahoma, and kind of seeing how users are able to create semantic networks of like linking body parts and food items. The link to that's here. This is one that was actually leveraging the AI agents and done at Michigan State. So they used AI-driven virtual agents to engage humans in natural health-related conversations in a VR setting. And they found that the VR versus text chat increased immersion, that there was an opposite gender effect where agents drew more gaze attention, more so for males, and then females rated agents more positively regardless of gender. And I guess I have to add the link to that one here. And this was one just using the context of being in a vehicle driving and using it, measuring motion of billboard recall and driving simulator. And so they had participants drive down a highway with eye tracking, and the billboards varied in emotional content, and they had some users have a distraction task of counting trash along the road. And they found that the distraction reduced exposure and memory. There was fewer fixations and shorter gaze, lower recall, and that the emotional messages were remembered better, but only when attention was available. And the gaze behavior did predict memory, so more fixations, better retention. And so these are some of the there's a lot more that we could share, and Dan will actually go into our partners in science where you could look at thousands of published studies, but I'm going to hand it back over to Dan to kind of highlight just the this particular one. I don't know why my web chat keeps getting in the way, but so I'm going to make Dan the presenter.
Thanks, Sato. I've been this has been my busiest webinar in a second, just because I've been answering as many questions as I can. I mean, I think we have 5 pages of Q&A questions. I don't think we're going to be able to get to everything in the Q&A, but maybe if you don't mind, Sato, I'll kind of moderate that section and just
I looked through the questions. I have answers for all of them, but we'll see.
Yeah, exactly. And I sent text message answers to basically all of them, I believe, as well. So, but yeah, I mean, anyone who's got the time to stick around, we'll go through this Q&A and hopefully clarify things, and we can still take your questions as we go too. So if there's something we haven't covered that you'd like us to talk about, please let us know. I'm just going to speak really quickly about kind of an exciting, almost expansion capability of SightLab. So this goes beyond even the tools that Sato's showing, which are really research focused, and is leveraging the multi-user capabilities for classroom-based learning. So this is an AR VR classroom that WorldViz built just a few months ago at LaSalle University outside of Boston. So this is showing, I'll just really pause it really quick. This is our immersive theater technology. So you can show 360 videos, you can show all sorts of different things in the theater. And then also it has touch capabilities. So a really kind of cool interface. This is a little bit different than VR, but what's cool is that it actually interfaces with the VR environment. These headset-based experiences can be output onto the wall. And basically, you've got this entire classroom. We have 12 headset users, everyone interacting in these virtual learning environments. So this is going beyond research and now going into actual, pedagogy, being in a virtual environment and having learning experiences with multiple students and subject matter experts. So it's a really exciting evolution of the technology, and it is based on SightLab. So I'd highly recommend checking out the case study page on our website. We're stoked on that, or I'm stoked on that for sure. The last thing that Sato just mentioned is this Partners in Science report. So this was a question that also came up in the presentation. Where do we get ideas for research? What are other people doing? What other publications are being published? This is something that we publish. We're actually overdue for one. So we've got one coming out this summer, but the most recent one has, I think, 350 or 250 published studies. In total, we have 560 published studies collected across the years. And this just shows you how many different disciplines are using virtual reality for research. You know, we've got architecture, engineering, construction, computer science, neuroscience, physiology, psychology, and we link to all of the papers. And basically, all of these use WorldViz technology in one way or another. So this is a great place to start if you're just looking for ideas about what is being published in VR right now. So this is just a quick final links page. And then definitely we've got one final poll for everybody. And I see Chris Lapointe saying that he was there at LaSalle, which is great. I remember you, Chris. That was awesome. Thanks for being there. I'm going to go ahead and send out um, this other poll. So for those who are still left, and I see we still have a lot of folks here, so really appreciate you sticking with us and the great feedback that we've gotten so far. So all right, we see 100% want AI integrations, advanced scripting customization, multi-user setups. So data analysis workflows. Okay, yeah. The more feedback we get on this, the better, because we are planning more webinars right now. So let your voice be heard. We definitely have an AI one planned, so I'm glad to see that. But I think maybe we have to move it up in the calendar if this is the winner here. So it's great to see multi-user setups being an interest as well. This is an area that WorldViz has a ton of experience in. So yeah, I think everybody get their votes in. I still see one or two more coming in. All right, this is great. Thank you so much, everyone who's voting here. I'm going to go ahead and share this out. So advanced scripting and customization, 19%. That's awesome. 13% how to use the GUIs for no-code experiment creation. 29% AI integrations. 23% multi-user setups, and then 16% data analysis workflows. So really, I mean, it sounds like they want everything, right? So
Well, the good news is that the AI is going to be one of the webinars we're planning on doing soon. Is going to be all about the AI integrations.
yeah,
And
I mean,
so,
we've only scratched the surface with that, and that was a lot of the Q&A too, Sato. So I'm just gonna
yes,
kind of call these out as we go, and maybe if you don't mind, I'll just kind of,
yeah. I mean, I
because I
have
think
answers
yeah.
for all of them. That some of them are pretty quick, I think, so we can just
Yeah,
run.
so the recording will be available. Where can we find the SightLab Assistant, Sato?
I think I put a link to that in the slides, which we'll share the slides with you. I mean, it is a custom GPT, so it should show up on the GPT store if you search SightLab Assistant, but we'll send you the direct link. And so, yeah, I could just quickly jump through these questions and just give some quick answers. We could do more deep follow-ups later if you want, but does that work?
That works. Perfect.
Okay, so yeah, to do segmentation to label ROIs, since we are built on Python, we can leverage like Python libraries that can do that. For instance, like OpenCV would be one that could kind of automatically segment ROIs. And so you just bring that in as like a Python library. Or you can also have an option for doing AI data analysis to automatically tag where somebody looked and labeling those objects using vision. Or another option is you can also just add a whole list, like using a CSV or whatever all of your objects are, and bring those in, and that works pretty easily.
The one thing
yeah,
that I also wanted to add to this, Sato, was that because we were just showing a static image, but this also works with video as well, right? So with 360
oh
video,
yeah,
back moving objects. So that wasn't a question that came up, but I just wanted, because that often does come up. And in our example, we just showed a static image, but you can say, for example, show a moving object and actually take data on that. So
yeah. So this is showing how this basically we're tracking a moving football player. I think well, I'll share this video. I mean, this shows you how that works. But yeah, that moving objects will also work. And which ones? Yeah, so obviously we can integrate a video with sound. So I think Dan answered some of these ones. Let me just look which ones maybe. The adding interaction, but like with button presses, I showed that with proximity sensors.
how would pupil size be normalized, Sato? I think that was a question that came up.
Yeah, so also that comes down to we have built-in data analysis tools since we import like the pandas library and different ones that allow you to take the data and normalize it. So I could share an example specific to pupil diameter size, but I would leverage the pandas for that. And yeah, I'll just share an example for that. The avatars. So yeah, there's a specific avatar library that we also have integrated with called Complete Characters. And those ones also have specific expressions that have been used in studies. But as I showed, you could use facial morphs. Yeah, so I answered that one.
Quick question that just came in the chat is what Python version is bundled? I believe it's 3.8, correct, Sato?
No, 3.13.
3.13. Okay, so I was off by
Yeah, we're ahead of the game.
Yeah.
What are the limitations in the demo software? Yeah, so we could share a trial version with you that is going to be limited to 5 minutes of execution time. Oh, Dan already answered. Okay, sorry. Yeah, I think you got that answered. It's communication in the virtual environment, voice-based. Well, it can be anything. It could be, we have options for speech recognition, so you could use voice to change things in the scene or interact with the avatars, or you could use text. And that also was the multi-user. You could use voice for that as well, just so we could share with you how that works. I think this is related.
Is there an example of a published paper that uses SightLab and an omnidirectional treadmill, Sato? I know you were working on this recently.
Well, I know we have customers using omnidirectional treadmills, and that comes in usually as like a controller. So it's like the same way you would move, like using a joystick. It's just using your movement on the treadmill. And so yeah, customers using like the Virtuix Omni One or the Cyberith, or we have those listed on our supported devices
but
page.
Do we have any examples of papers or experiments that have been published with that yet, or would we have to double check that?
I'd have to double check that.
Okay.
Okay, so the sample frequency is when you're doing the VR display, then it's limited to the refresh rate of the display itself, so that can vary. But there are some capabilities to get a higher sample rate, like if you're using the Vario, for instance, since we can synchronize with the data from the Vario, they're collecting at 200 hertz, and that synchronized data could be brought in. But generally, it's synchronized with the display sample rate.
Yeah.
Let's see. Yeah, so we do support Vive Pro I with People Labs. That's the latest version. I think it's 2.3, but that we have that tested even recently with the Vive Pro I People Labs, and that works.
Yeah.
I think there was another question about, oh yeah, use of AI and psychiatry revisions. I mean, I think if you're using like the AI agents, I think it's really just comes down to testing how it's going to respond based off of different prompts. I mean, I think nowadays the AI, if you're using the ChatGPT or Anthropic or Gemini, they have pretty good guardrails if you want to make sure that it kind of stays within a certain parameter. But since we can also support the offline models that you could do custom training on, you could make it very, very refined that way. But I could share also some information about that later.
Yeah, I highly recommend checking out the basically what I'm sharing out on the screen share right now. The AI intelligent agent documentation is a great place to start for this, because it's just got and just the help.worldviz.com/SightLab website in general is going to have an absolute ton of material for you to check out. So yeah, that's definitely trying to think what other topics we might want to cover in this Q&A.
And there were a couple of questions about communication in the multi-user.
That'd be great. Maybe Sato, you can just speak really quickly.
Yeah, we could use speech recognition for communication, or if you're just talking about multi-user, then that's using like leverage different speech tools like Discord that you would then have the speech between, like if you have a co-located user, or you could use text to either communicate with an avatar or communicate with each other. I mean, there's different options.
Yeah, I think the main point is that, you know, there's multiple ways of having multi-user VR setups, right? So you can have people in the same room wearing headsets talking to each other normally, or you can have remote collaboration where, Sato's in California, I'm in New York. We can both put on headsets and then use, I think you mentioned Discord, but there's a lot of different techniques for having voice synchronized with your avatar. And then also kind of covered in that AI agents page, there's a lot of ways that you can have NPC characters, right, with multiple users. And yeah, so that is a way to, there's basically a lot of different ways. If you want live people interacting with each other, we support that. If you want pre-recorded avatars or even AI intelligent avatars, we support that. You can have custom animations for facial expressions. There's a whole bunch of different things that you can do. I mean, some recent stuff that we've done is basically very accelerated NPC environments where we can have custom scripts. So an NPC character can use an AI voice generation tool, just like 11 Labs, and basically just speak a script that you type for them. So that's a really powerful tool for doing a whole lot of human interaction research.
Oh, and I saw one
right
more
now.
question just came in about support for cave and 3D wall setups. So yeah, I think you could speak to that, Dan, because we obviously have a lot of
Yeah, so that's not
experience
really
with that.
exactly the topic of today's discussion, but in terms of integration of Cave or 3D wall setups with Unity, that is something that I think we'd have to discuss on a one-on-one basis. There are certainly approaches to that. We have some partners who provide commercial support for that, and then WorldViz has also supported that in the past as well. So we really didn't talk about projection VR or caves at all today, but it is something that we have a ton of experience with. If you go to our VR Labs, Projection VR Labs page, you'll see that we actually have our own line of projection VR environments that we provide. So this is really cool technology, but again, it's not something that we really covered in our talk today. So if you're interested in learning more about that, you're welcome to reach out to us. There's some really cool use cases for this, both with Vizard and also with other development tools such as Unity. So it's just a different technology than HMD is.
Yeah, and I mean, so this also will work because one thing, I don't know if it was clear enough with the hardware configurator tool, VizConnect, that comes with our software, you can run an experiment in a projection VR cave. I mean, not Unity, but based off of our engine, and you don't have to change your code. It'll just run in the cave, or it'll just run in a headset, or it'll run in desktop. But yeah, I don't know if we should wrap it up at this point, or
Yeah, I think that's probably a good place to wrap it up. We got one question about the Discord integration, but I think we can basically send links to specific documentation at this point.
yeah.
If you go to the multi-user, running a session with multi-user, there's a whole bunch of different details here about how to get this all set up.
Yeah, and for the
And
multi-user, I mean, you
yeah,
basically just people put on their headsets, they join as a client, as a server, and you could connect immediately. The voice is the only thing where you would run a separate software right now through Discord, but we're looking at integrating Mumble directly. Right now, it's going to leverage just running Discord, which I have the outline of how to do that is pretty straightforward. Or you could use other ones, just using the microphone from your headset.
yeah, and it's awesome. So some great positive feedback from everybody in the chat. We really appreciate you all sticking with us. And yeah, look for our next webinar. We've got a couple planned, like Sato said, one on AI integrations, and then another for how our core Vizard software is used in computer science education. So some really exciting topics coming up. And yeah, if you let me actually put up our final slide here. Connect with us. So we have a YouTube page with a ton of tutorials that you can check out. WorldViz.com is a great resource. Our documentation pages, help.worldviz.com. And then if you've got questions about pricing, licensing, reach out to sales@worldviz.com. We'd be happy to
Yeah,
talk.
we can provide pricing. I see some people asking about that too. I guess Dan can follow up with that directly.
Yep, absolutely.
Okay.
So awesome. All right, thanks everybody. Hopefully see you in the next one. So let me just see, how do I close this webinar now?
It's never going to close. Or
Yeah.
um,
Let me just see.
I could just click the top
Yeah,
quit button.
can you
Okay,
click the stop one? Thanks,
see y'all
awesome.
later.
All right, take care, everybody.